Hey, and we are live. Thank you to everyone who is tuning in for this week's Aligned Guest Stream, where I have the pleasure of hosting Sylvie and Adam, who are the co-founders of Atomiq Labs. And this is going to be an interesting one because it's not our usual content. I mean, in a way it is. We're still talking about trustless infrastructure for doing things on-chain. But I think this is the first time we are talking about Bitcoin and I guess specifically how it acts as a settlement layer for cross-chain swaps and how Atomiq Labs is making this happen. So Sylvie, Adam, thank you for joining. It's great to meet you. It's great to have you here. How are you doing today?
Pretty good.
Yeah, thanks for having us. Yeah.
Thank you for joining. I'm really excited to learn more about what you're working on and what's happening in the world of Bitcoin right now. So maybe we'll start with introductions. I'd love to hear about your own backgrounds and Atomiq Labs and the whole story behind how you came to work on this.
Yeah, maybe I'll start on that one. I'm Sylvie. I'm the co-founder and CEO of Atomiq Labs. I have a TradFi background. I initially started my career in banking, did management consulting, and worked in two fintechs as the right hand of the CEOs, one in the US in California and the other one in Berlin, where I'm also currently based. And yeah, 4 years ago, I met this guy, Adam, and he completely orange pilled me. And we're working together ever since. Worked on a payment gateway before and now on Atomiq for 2.5 years. And yeah, along the way, I also discovered that Bitcoin and myself share the same birth date. I was born on the 3rd of January, when the very first Bitcoin Genesis block was mined in 2009. I have to say, though, that I was born a couple of years earlier, not in 2009.
That would be very impressive.
Yeah, and this is it about my personal background, and now I'll pass it on to Adam.
Yeah, I think it's quite crazy. Like we are working together for 4 years by now, and worked on this is basically the third, so to say, project that we work on together. And yeah, it's just super cool. So yeah, I'm Adam. I'm responsible for all things tech on the team, and also like research and other things. Yeah, I got into crypto back in 2017. Back when the big ICO craze happened and Ethereum was pumping and everyone was talking about flipping. Was crazy times back then. So I started with Ethereum and then I kind of slowly gravitated towards Bitcoin. Eventually, I got really hooked on the idea of the Bitcoin Light Network, and that's when I basically transitioned into like mainly focusing on Bitcoin. I started thinking like what can I build there? What would make sense? And that's when I met with Sylvie and we first started doing this like Lightning payment gateway, because of course it's the first thing that you think about when you think about Lightning. That didn't go as well, so we eventually pivoted, and we pivoted especially because we needed a solution like Atomiq that we are building now for our previous startup, because we were trying to see how we can swap stable coins into Bitcoin in a fully trustless way. And you wouldn't imagine that this is such a hassle, but it was. That the only solution we found to do that was basically Ren Bridge, which then went bust like 2 weeks after, because the whole FTX thing happened. And there is this like little known thing, or maybe like more known thing, is that FTX, when they invested in projects, they kind of forced them to hold their treasuries on the FTX platform. So that when they went bust, a lot of projects were wiped off the market because they just had their whole treasuries stolen, or they went away. So then there wasn't any solution that we could use. So we started thinking about like, hey, can we build something on our own? And that's where all this started. That's when we started Atomiq to mainly focus on swapping assets on other chains into Bitcoin, and we do it in a novel way by using the light client of Bitcoin, basically. So we leverage the proof of work consensus of Bitcoin and we are able to verify that consensus inside of smart contracts of other chains, and that then gives us read access into Bitcoin, so we can prove and verify that all the transactions or like any transaction actually happened and it was confirmed with Bitcoin. And this is then a trustless primitive upon which we can build our swaps on. And yeah, so this is like about me and about Atomiq.
Very cool. Very cool. Yeah, we're definitely going to get into a lot more detail. I want to ask you a lot of questions about the the light clients and how you're actually getting that state and being able to make the swaps happen. It's interesting. You mentioned how there weren't really any good solutions for swapping stables and Bitcoin, and I think this is maybe an interesting thing to discuss a little bit, because I mean, I guess as you get more into crypto and you start realizing like that some of these things are not actually possible in a trustless way. Like all the different chains are kind of their own fragmented or siloed ecosystems, and usually you have to rely on some kind of centralized or trusted entity to facilitate swapping between different chains, right?
That seems to be the unfortunate status quo at this point. And this is what we're trying to change. And also, it's not just stablecoins, right? It's any kind of assets, and on all the other chains, like you're trying to get them to Bitcoin. There's very little amount of bridges that support Bitcoin in the first place. And even those that support it basically operate on a multi-sig assumption. Basically, they run several validators, which then custody the funds of the users and process the swaps. And this is not trustless. You're just delegating trust to some third party, be it a centralized solution or be it a multi-sig. Doesn't really matter. You're losing your self custody.
No, and in our opinion, it's also, cross-chain shouldn't mean like, oh, cross your fingers that no one rugs you and colludes. So we actually want to make this we want to create a system, and to some part we have created it already, that really is trustless, because my heart is always bleeding a bit when I see these like marketing announcements in crypto, where like solutions tell others, oh yeah, we're trustless, and then you look under the hood and it's definitely everything but trustless. And I think this is also like removing, a lot of trust into crypto in the end, because I mean, we are all in here because, or that's at least my assumption, that we're all here because we believe in like a decentralized and trustless world. And we're really here because we want to make that happen. And
yeah, or at least we believe in the importance of having these sorts of systems be decentralized and trustless and censorship resistant, and we want to build them because this allows us to transact more freely or efficiently or whatever, right? At least that's why I'm here. So I'm glad you guys feel the same way.
I mean, it's like not trusting someone else with your money, right? That's the root thing.
Yeah.
Like you own something. You should be the only one who is able to spend it, and not someone else rugging you and taking those funds from you.
Yeah, it's
no,
I was going to say it's a way to better guarantee freedom and sovereignty ultimately.
Exactly. Yep.
Yeah, and ultimately, if we have trusted systems only, then we can just go back to databases. Then, in our opinion, we don't need blockchains.
Exactly. So yeah, okay. Let's talk about Atomiq. So, Adam, you touched on a few things already, but I would love just like a more detailed breakdown of, or at least, well, maybe at a high level. We don't have to go super deep, but I am curious to hear more about how your cross-chain swaps work. And it sounds like it's based upon this light client and like ability to verify Bitcoin's state, I'm guessing, which I'm going to admit I don't know too much about Bitcoin, so feel free to explain things.
Yeah, I mean, like Bitcoin status is quite simple. It's literally just transactions, right? There is no like state tree like in Ethereum where you would have the state of the chain stored there. You basically have transactions in a block. You have like a big Merkle tree with all the transactions. Then the root is in the block header, and you just take any transaction, take the block header. You're able to prove that transaction is there. It's actually not that crazy complex to do it. And also when it comes to the Bitcoin light client, like you don't realize how easy and how simple it is to verify Bitcoin. At least the proof of work part, the consensus part. It's literally like you can do so for like 5,000 gas on Ethereum. The most of the cost there is actually for storage, right? Because you pay like 20,000 gas for occupying a single storage slot, but the verification costs just 5,000 gas. So you can really make it very efficient. So there is also not any need to use zero knowledge proofs there, because you don't need to compress anything. Actually, if you were to do it in a ZK proof, you would probably pay 10 times as much on chain to verify that. So this allows us to have this like very lightweight light client of Bitcoin that can then verify the whole like state or all the transactions on Bitcoin. And I mean, once you have that, then it's quite simple to start building swaps on top of that, right? You can just create, and that's how we do it. That's how we do it. Is that you just put funds into an escrow, and then the other party can only claim the funds if they send a Bitcoin transaction to your address, sending this exact amount, right? And it's like on a high level, it's a very simple system. And this can work the other way around, right? Like you can also have the other party saying, okay, here is the money. You can claim the money as soon as you send me the transaction to this Bitcoin address of this amount, and then you can claim the funds. And this is how it's basically trustless, because it just depends on the Bitcoin Light client, which basically anyone can. Also, important to know that this light client is not permissioned at all. Like really anyone can submit block headers to that light client, right?
Okay. So let me make sure I understand this correctly. So basically, say I want to swap Bitcoin to Solana. You're live on Bitcoin and Solana. You support those swaps. Mm-hmm. I have some Bitcoin and I want some Solana on Solana. I basically would send the Bitcoin, like there's a smart contract. I send Bitcoin to it somehow, or rather, there's a smart contract that's saying when this Bitcoin is sent to this correct address, mm-hmm. I will release the Solana to specified address.
So what I always like to say is, like, we basically have a little, let's say, like a safe or a vault on Solana, where you put in, where either you or the liquidity provider puts in the sol. And then how does the other party get access to this little vault? The key to unlock the vault is basically the successful Bitcoin transaction. And this can go both ways. You can do like the user can swap Bitcoin into Solana or Solana into Bitcoin.
Okay. So the direction Bitcoin to Solana, that seems kind of straightforward, because it's like the smart contract, I assume here, is living on Solana. Yep. But it's using this Bitcoin Lite client to ensure that the BTC was sent to the specified address on Bitcoin, on the Bitcoin network. What about going the other direction? Like, what if I have Solana and I want to get Bitcoin, right? Like, how is there a smart contract on Bitcoin? That is this where BitVM comes in, or no?
No. So this is really interesting, because for most of the people, it's the actual like BTC to Solana that's more hard to understand. But for you, it's the other way around. But okay, I mean, so it works in a very similar way, that you as a user, you just put funds into this escrow, and then the counterparty needs to send you Bitcoin, right? So it's a I think, to understand it, it's a peer-to-peer protocol, right? It's not like peer-to-pool. So there is actually a party, which we call a market maker or a liquidity provider, who actually runs a node, and then you basically coordinate with that person off chain, and you do a peer-to-peer swap. Even though you're doing a peer-to-peer swap with a single entity, it's still trustless, because it's done using this trustless infrastructure, which is the light client and these escrows, right?
Okay. I see. So it really is the same idea. It's just the SOL that I send to this contract for the counterparty to receive will only be released once the light client detects that they have sent the BTC to my address on Bitcoin. Okay, that seems
and if that doesn't happen, you can just refund after some time. And currently there is so currently it's like a reputation based thing. So if you have an LP that you need to refund from because he didn't do his part, then he just gets like minus reputation. But we are working, and then the next iteration will have this called like a slashable bonds as well there. So if an LP doesn't go through with the swap, you can refund, and you also get compensated for the fact that you had to have the funds locked there for some time.
Okay.
So we're really like trying to improve the system even more. And also, like, when it comes to swaps, especially from Bitcoin and Solana, there is this one big issue that we had, and that's like, so if you think about it, you know, if the LP first puts up the, let's say, SOL tokens into an escrow, but the user never comes, you know, the user never sends the Bitcoin. And what that means is now the LP has his funds locked up in this escrow, and he needs to wait till the timeout to be able to refund. So he needs to pay for the on-chain transaction. He has his liquidity locked, and this is just not great because the user can just yeah, it's a capital lock, and like the users need to and so the way we tried to mitigate that at first was that users actually have to first put up like a security deposit for this to not happen. And if this were to happen, then the LP would kind of get compensated for that fact. But then that doesn't work really well, because when you want to swap Bitcoin to Solana, you don't have any Solana to fund the security deposit with. So yeah, it was like a pretty clunky solution. So that's why we had to like think differently and kind of improve on that system. And then we figured out, okay, maybe we can do this better. And we've been able to actually improve on this system, whereas there is actually no initialization needed on the side of like the Solana or what we call smart chains, right? So that would be your StarkNet, your EVM chains and others. So we made it in a way that we and this is gonna like be quite confusing. This is not as easy to explain as this like escrow thing. So what we basically did is that an LP puts up a funds before, like just once, like before any kind of swap happens, and then he attaches those funds on a specific UTXO and Bitcoin. So Bitcoin uses the UTXO model, right? So you don't have like an account and then nonces that you increase. You have an UTXO. UTXO is like a piece of coins that you can spend, and that it specifies the public key, or basically there's like a script. There's a simplified script in Bitcoin that can say, okay, this person, or well, not this person, like there is this conditions you need to pass these conditions, and then you can spend that UTXO, right? So what we do is we attach this amount that lives on the smart chain to a UTXO on Bitcoin, and then we basically, when you're gonna swap, this UTXO is gonna be one of the inputs in the transaction. And then what we do on the smart chain, we verify that, okay, if there was a transaction that's supposed to pay out to some other user, we check, okay, is that UTXO there that was supposed to be there? And then if it's there, then you just pay out to the user. And what this allows you to do is you can have a clear ordering of swaps as they happen. So it cannot happen that, because like a naive approach would be that an LP locks funds into a vault, and then you just let users send in BTC and then get the funds from the vault when they can prove that they sent BTC to this address, right? But that's not very secure, because what can happen is that the LP can just withdraw the funds from the vault in the meantime, so that he receives Bitcoin, but the other party doesn't get anything. He can also just front run, so he can also send multiple transactions on Bitcoin before this guy, like paying higher fee, right? And then he could drain that vault first before a user has a way to do it. And that's why we need these UTXO chains. So you basically order the withdrawals or order the swap outputs from the vault in a deterministic way with these UTXOs. And make it so that user can be 100% sure that when he comes, that there's going to be money left for him, and he's going to be able to get the funds.
Okay.
As you can see, we're security maxis.
That's really good to hear. Yeah, I think I follow this. It sort of makes sense, and honestly, the whole system sounds very elegant. I'm curious. So you're like Atomiq is live for cross-chain swaps between Bitcoin and Solana already. what was needed for this to exist? Like, why didn't anyone build this sooner? Was it the light client that had to be built? Was it just realizing that this architecture worked?
Yeah, that's a good question. Like it seems like the thing with these like validator-based multi-sig bridges got so normalized in the market that if someone just started thinking about, oh, we're gonna build a bridge, they just used the validators because they were the easiest. Everyone was using that, and people are kind of like conditioned to accept that as a fact. And like we were different, right? Because we came from the side of Bitcoin where you cannot really LARP about something being trustless and it not being trustless, right? So we're like, okay, we need a way that to do these swaps that's solid, right? That's super solid. And I mean the first approach and then that would work is the HTLC swaps, right? Like this old way of doing atomic swaps with the hash locks. And we've been looking into that, and it's interesting because it's trustless, but it still has some drawbacks because there is a liveness requirement on both sides of the trade. There is basically the free option problem. So what I explained to you with our first swap design, that there was a way how you can lock up funds of the LP and then not go through with the swap. The HTLCs have the very same issue, whereas with the Light client it can be solved. With the HTLCs, it's an issue that cannot be solved. And what this leads to is a higher swap fees because you basically need to cover the potential losses or potential risk of someone just locking up the capital of the LP, and also the UX issues with having to be live and online for the swap to go through. And this doesn't seem like a big requirement to be alive for the swap to go through, but then you must realize like Bitcoin block times are 10 minutes, and this is just average. Like at some point you can be there sitting for 2 hours without any Bitcoin block, and then that means that for your swap to go through you need to have your browser open for up to 2 hours, and if you close it, the swap just fails, right? Yeah. So we were okay, like trying to research alternatives. We actually found an implementation of the Bitcoin Light client from the guys over at Interlay, or they were building Interlay before. Now they're building Bob, the Alexei and Dominic Hartz, I think his name. And so they wrote it, but it was not very efficient because it was just storing the full block struct in a state, basically in a storage variable on Ethereum. It was like crazy expensive. Like you would pay 180,000 gas for a single Bitcoin block header. So we took that and we optimized a lot of it down to writing YUL, which is assembly for EVM, and also optimizing quite a lot the storage aspect of the things. And we were able to get it down to 25,000 gas per block header, which is where we are sitting right now. And I think that's a great improvement, and then that will allow us to make this possible even on mainnet, because before it was like just way too expensive. And yeah, then I mean on Solana, the cost aspect is not that big of an issue. It's a cheap chain anyway. But this anyway helped us to then port the EVM implementation over to Solana, to the SVM world, and use it there. And I mean, yeah, we've been using it there ever since for 2 years now, and never had any issues with that. So
okay. Yeah, so you've been talking about gas, and is that like EVM gas prices?
Yeah.
Like, did you initially implement this for Ethereum?
Yeah. Okay. So this is like the part that I didn't share. So yes, the first version was an EVM one because we were building it because we needed it, and we were back then we were using Polygon, which is EVM. So that's why we first built it on EVM, and then kind of like pivoted towards doing it full time. And then there was a Solana hackathon running, so we're like, okay, let's just join, let's just try it. So we joined. We built this for Solana in a month long span. and it was basically live on testnet, and you could use it. And we won the first place for the Germany with that. We got an honorable mention, the global hackathon, and then Solana was also like supporting us. We got a grant from Solana to just keep building, and yeah, that's basically what allowed us to get to the stage that we are now. I mean, without that, we would probably just die at that point. So it's great.
But
No,
you have it. No, go ahead, please.
Here. No, I think maybe let me summarize a bit what Adam just said. So we basically took the convenience and the good UX of like a validator and multisig based swaps and married it with the security of atomic swaps. That's why we also like call ourselves like next gen atomic swaps, because we basically, like, for example, the LP griefing or ghosting. It's like in dating. You as a user, you could just go and say, okay, I'll initiate that swap. The LP locks up the money, and then I say, oh, I actually don't want to go on a date with you anymore, so bye. You could even like take this further and say you basically time the market if it's like an asset that is not like BTC to rep BTC, because there is no price risk. But let's say there is like BTC to ETH, for example. Then you could simply like wait for almost the entire time lock and see in which direction the market is moving. And if you're the user and the market is moving into like a favorable direction for you, then you execute the swap. And if not, then you don't. And we just basically took this system and improved it a lot, especially with these edge cases, so that both LP and user cannot rug each other.
Okay. Yeah. No. I love it. I mean, so tell me about Atomiq now. Like, what is the state? Like, I don't know if you can talk about volume or usage. I'm just genuinely curious. Like, because I don't know too much about the sort of Bitcoin side of things and the current players. Like, where is the volume happening between Bitcoin and other chains in terms of trustless swapping? Does that really happen? Is it mostly done on centralized exchanges? What do you support right now? And then, of course, I want to ask about what is the next phase? What do you plan on supporting? What kind of technology is being developed or advanced within Bitcoin that's enabling new things? But like from here to future.
So we are currently not sharing the volume numbers. That's internal. But what I can tell you is that like we have seen increased volumes between Bitcoin and StarkNet recently, because they just launched their BTCFi initiative, and we have seen like a real spike in volume there. We're also like getting great feedback on the StarkNet end. We're already like integrated into Bravos wallet, or our SDK is, as well as Xverse. And we're also really pushing that end of like having our SDK integrated into other protocols, wallets, dexes, aggregators, because in our opinion, this is like the best way for distribution. It's basically like the end state of Atomiq is users not even knowing that they're using Atomiq. A user might not even know. And I think this is a big problem in the market right now, that like most users don't know how these bridges actually function and how trusted in a sense they actually are. So I think users are just like, okay, I need to move from like Solana to Ethereum. So this is the way how I'll do it, without even like questioning how this actually works.
And like, you don't have a choice right now, right? That's the thing. I mean, I also do the same, because there is no other way, right? Like if I want to go from Sol to ETH, like there is no like trustless alternative. There are ways to do it either centralized, or there is a way to do it with this like multi-sig validator assumption, and you just have to eat that risk as a user, but not only as a user, also as an LP, right? So there is a certain risk and risk premium that you need to bake into your quotes as a solver on these networks, because there is some inherent risk of this happening. And this just completely gets away with Atomiq, because then you don't have any counterparty risk. You don't need to charge any risk premium there. And also for the user, it's better peace of mind to just know that, you know, this swap is either gonna go through, or I'm gonna get refunded and compensated for that.
And another thing is also with Atomiq, there's also like no MEV or front running. That's completely eliminated.
Because it's just, you know, you're entering into this one peer-to-peer swap basically. that's agreed upon, and that's what gets executed.
So the matching happens purely off chain, and then the on chain part is just the winning quote that hits the chain eventually. So there is no way how like anyone can front run that or extract some MEV from that.
So you touched on a very interesting point, because you also asked which chains were going live next. So
yes.
we are currently live on Citra's testnet. Citra is a DK rollup on Bitcoin, and Citra is also one of the Bitcoin L2s that will have a BitVM bridge. So BitVM is like trust minimized bridging, and for that you need a solution like Atomiq, because as a Bitcoin L2, you simply have to make the decision of choosing one increment and one increment only to deposit and withdraw. So this is not very retail friendly, because if that limit is, for example, set at 10 BTC, then you could only like move in 10 BTC and out 10 BTC. But this is not like retail won't use this. And this is where we come in, because our liquidity providers use the BitVM bridge, and we just can slice up the CBTC in this instance, and users can swap any amount that they want.
And because it's still fully trustless, you're not layering another trust assumption on top of the existing one, which is the BTVM, basically honest, not even an honest minority, existential minority it's called. So for the BTVM bridge, you just need one honest operator out of the full operator set for the bridge to stay secure, right? Which I think is like it's pretty good improvement over existing status quo of like, you know, multi-sig bridges having honest majority assumption. And it's, you know, there are like two things, like, you know, a lot of people don't talk about this, but there is, even though there is an honest majority assumption, so that like 2/3 of the multisig need to agree to do something, there is also this other part which doesn't get talked about much, which is that if you collude, if 1/3 of the multisig participant collude, they can freeze the funds, right? Because then there cannot ever be a 2/3 majority if 1/3 just decides to not do anything, right? So there's like two kind of issues with the multisig approach, and then BitVM is like really pushing the limit of what's possible with Bitcoin and bridging Bitcoin to other systems.
Yeah, 1 of n is definitely better than any higher number than 1 of n, especially in this case. So BitVM, can you explain BitVM a bit? Because because I've also seen BitVM 2 and BitVM 3, and I know StarkNet has shared some stuff about this, some work they're doing on it, but I honestly haven't had a chance to really wrap my head around BitVM. It sounds like it is a trustless bridging solution for Bitcoin to Bitcoin L2s. But that's the limit of that's all I can say about it myself.
Right. I mean, okay, we can start with the beginning. I hope this doesn't get very long. But essentially, so BitVM 1 originally was a way how you can have two parties, approver and a verifier, and they can like approver can prove that some computation was run correctly, right? And the way to do this is that you first have the optimistic way that, you know, the prover just sends a valid computation and nothing happens, and then the on-chain part is only used in a pessimistic case, and in that way you can play this challenge response game. I think similar, like I'm not sure of the state of things of optimistic rollups on Ethereum, but there still has to be like some back and forth to
like a bisection game.
The bisection game, yeah, exactly. So it's like exactly the same on Bitcoin in a two-party setting. So BitVM 1 was just that. You have a bisection game between two participants, and then in the bisection game, the party that lied basically loses, be it either the prover or the verifier. And this was a primitive upon which it was thought that you can start building bridges. And like you can, there are teams like, for example, BitVMX that are still building bridges on this first approach. But a lot of the other projects just said, okay, this is not good because this challenge response game is like quite long. It was like, 30 back and forth. So that was not really great, because if you need like a week to have like a week timeout for a single step, then you're gonna end up taking 6 months just to bisect the one program. So Then BitVM 2 came along, and the BitVM 2 took a different paradigm and was like, okay, maybe we can just have a very focused. Let me add. So BitVM 1 was like general purpose computation, right? You can have a program that you bisect, and then you can prove that the program was run correctly. In the BitVM 2 approach, we kind of, or like the BitVM 2 approach had this idea of, okay, let's just write a GROT16 verifier inside this BitVM thing. So we'll just do one thing, a GROT16 verifier, because with GROT16 verifier you can verify any ZK proof that you compute over any computation of chain, right? And the way they did that is they implemented a GROT16 verifier in script. So script is this like simple, I was talking about this is very simple language that Bitcoin uses. It has like no for loops. It's very limited. The arithmetics is kind of weird, like 32 bits, but with like an additional bit of sign, and then like there's a lot of nuances there. So you literally have to like implement like rudimentary things like multiplication of numbers. So there is no multiplication of code, for example, right? So you need to do multiplications that are unrolled with additions, or do lookup table or something like that. So this script ended up being like 3 gigabytes, I think, in total. And the most you can push into a Bitcoin block is 4 megabytes. So it was like, okay, yeah, this is not gonna really work by just showing it there like at once. So what they realized is that they can split the script into multiple chunks. So you literally split the script into 1,000 chunks, and then every chunk you can check on Bitcoin. And then what you do is you do the computation, and then you challenge it based on a specific chunk. So if you know that there is an error, or there was like a misbehavior on the other party in this specific chunk, you just put that chunk on chain. The Bitcoin executes that part of the GROT16 verifier, and you can then prove or disprove that this prover lied to you or not. And again, this is like a primitive on which you can build bridges, because now you can have you can basically verify any computation on top of Bitcoin. And this is what Citria went live, is on testnet with. This is what Alpine is right now using on their testnet. But the problem with that, I think, is quite obvious. Like, you're putting like big chunks, like of 3 megabytes of transaction data on Bitcoin, which gets very expensive. And that wouldn't be the biggest problem. The biggest problem is that because it's so expensive, the bond that these like prover and verifier needs to post to be able for this to make economic sense is quite high. So that's why we have this like 10 BTC that has to be there, and then the prover and verifier has to secure that with an additional 7 BTC. You know, so it was like
a lot of money,
crazy amounts. And then BitVM 3 came along, and this is building on this idea of garbled circuits, which means that you can have a binary, a Boolean circuit, so with like AND gates, OR gates, and stuff, and you can construct a garbled circuit out of it, such that when the inputs are correct or incorrect, you reveal a preimage at the end. So it's there is this like it's quite complex, quite elaborate. That you have some inputs, and then these inputs are like hash preimages as well, and then you kind of hash them, and then in the end, if it's correct, you can decrypt one preimage. If it's incorrect, you can decrypt other preimage. So then the proof on chain gets very, very simple, because now you just need to prove on chain that, okay, this party knows this preimage or knows the other preimage, and that's how you can then check if the computation is correct or not. Okay. And now these kind of challenge response gets very, very, very cheap, right? Because now you're putting like a transaction of several kilobytes at most on Bitcoin. So it makes it like much more capital efficient when it comes to the bond that these verifier and prover needs to put to make economic sense out of this. But yeah, you still have this issue of like a single increment that can be bridged. It's still like 10 BTC. Maybe with BTC 3 it can get lower to 5 BTC, but it's still like a big UX hurdle, and also a big, like, yeah, you just, like, as a regular user, you wouldn't go and check out the new rollup with 5 BTC in, right? So that's why then we're still kind of like needed as a critical piece of infrastructure there, really, to make it possible for users to go in and out with any amounts and do so with a better UX, and also with also faster, right? Because the kind of like a bridge would need to wait for finality of Bitcoin, whereas our bridge can do less because we are bridging smaller amounts. So we are fine with the risk, or the LPs are fine with the risk, right?
I see. Okay, cool. So it's like you guys are using BitVM to enable the atomic swaps cross-chain, or your LP.
not a correct way to put it. Like the BitVM. So we are just a swap solution, right? Like whatever asset you have on a smart chain, be it a Bitcoin rollup, be it Ethereum, be it Ethereum L2, be it Solana, we allow trustless swap between assets that live there and Bitcoin.
Okay.
BitVM gives you a version of Wrap BTC, like WBTC from BitGo, but with better trust assumptions, because now, well, I mean, WBTC is the worst offender of them all, right? Because it's just centrally issued by BitGo. But then you have at least you have TBTC, for example, which is backed by this 100 people, or supposedly 100 people Multisig, right? And BitVM takes it a step further and creates a Bitcoin packed token that's backed by a party, like multiple parties, like as operator said, and then you just rely on one of them staying honest for the bridge to still work, right? And because that bridge is clunky to use, we have Atomiq, which is able to do these swaps between these assets.
Okay, gotcha. So BitVM allows some wrap BTC to be on Bitcoin L2s, but for users, they wouldn't want to use that bridge. It would not make sense for them. So
exactly. And I mean, this is not only about Bitcoin L2s, right? Like with this BitVM paradigm, you can bridge Bitcoin to any other chain as well. It doesn't just have to be Bitcoin L2s. It can be, Solana, it can be Ethereum, it can be any established chain.
Yeah. I know StarkNet is doing this, right? So
yeah, like just recently they announced partnership with Alpen to build this, and I think this is much needed, because now they have all this BTCFi happening, right? So they are rewarding people to bring their Bitcoin, and you can stake your Bitcoin, but all the Bitcoin, well, not all of it, but most of it is either WBTC, which is just custodied by BitGo, is LBTC, which is just Lombard. And then there's CBTC, which is a little bit better, but it's still a multisig, right? So if they can really get this trust minimized version of Bitcoin there, I think that would be really cool. And that would also, I think, make a lot of Bitcoiners as well be more happy to try out StarkNet as well, because now they wouldn't have this additional trust assumptions.
No, totally. I mean, one thing that kind of gripped my attention with the Ethereum ecosystem was DeFi, for example, where it's okay, I have some ETH that I maybe bought on a centralized exchange or in my brokerage, and then I saw it go up in price, and I thought, oh, cool, I can withdraw this to my own wallet, and I can put this into a lending protocol, or I can bridge this to other places, or buy an NFT and do all these things. And it makes sense to actually hold things on chain and put these assets to work, right? And there's such a large amount of liquidity in Bitcoin, and it's still by far obviously the number one crypto asset by market cap, but it's mostly just sitting there. And now this kind of Bitcoin BTCFi renaissance is creating or enabling velocity within this market.
The reason it's sitting there.
Sorry, go ahead, Adam.
Yeah, it's just the risk of moving it anywhere else is just so high that it doesn't warrant the yield that you get there, right? So that's the issue.
And I think one of the parties that we forgot to throw in the mix is all the digital asset treasuries that are mostly around Bitcoin. Because our assumption is also that once there is something like a BitVM bridge out there that is offering trust minimized bridging, then in that case, we believe that they would also want to put up their Bitcoin to work.
And there is this other part, if you're a big company, the treasury company, you can also join the BitVM operator set. And what this gives you is, because it's one of n, now it's trustless for you, because you can be that one who is honest, right? So if you're really big, you can make it trustless for you if you want to, which is, I think, another kind of interesting concept there. But going back into these like, okay, like Bitcoiners and we've been also thinking a lot about how to get Bitcoiners where they are, and we realized, okay, like we cannot expect Bitcoiners to have like a MetaMask. We cannot expect them to have like a Bravos wallet for StarkNet. You know, Bitcoiners are simply not used to that. So we've been thinking about it, and we have this feature that's called Swap Plus. And what this allows you to do is go directly from Bitcoin to executing a specific action on the side of the smart chain. So you could, in a single click, go from native Bitcoin into a yield strategy on top of Ethereum, or you can borrow stablecoins against your Bitcoin collateral in a fully automatic way, such that you don't need to do any additional interaction with the thing. And then you can get the either the position asset or the stable coins. And then I mean, there is this thing called account abstraction, right? And this is especially big on StarkNet, where you could have a Bitcoin wallet controlling a StarkNet account. So you don't require the Bitcoin people to set up any additional things. They don't even need to know that there is StarkNet or there is EVM behind the things. For them, it just like looks like, yeah, you come to this website, you deposit your native BTC in, you get yield on the other side, or on the side system, on the EVM or on the StarkNet, and then once you want to withdraw, you just withdraw back into native Bitcoin.
Okay, cool. So all the gas would be sort of taken care of by the Bitcoin account that the user has.
Yes, I mean, yeah, you would go in with BTC, then yeah, you would get some wrapped version of BTC on the other side that gets deposited to these funds, and like and this is like kind of cool when it comes to StarkNet, that you have this native account abstraction, and then it's quite easy to do paymasters there as well. So you can literally sponsor the fee for your users, and the fee is usually just 0.1 cent anyway. So you might as well sponsor 10 transactions for your users.
An L2, yeah.
And if not,
Yeah.
you can also use the Bitcoin asset as to pay for gas with the paymaster as well. So that also works completely fine. And I think like StarkNet is really well positioned when it comes to this, to have a very easy platform to use, that you don't even need to think about StarkNet when using it.
Yeah, no, that's really cool. So yeah, you mentioned before we started that this new product you guys are launching, Swap Plus, is coming soon. I mean, this sounds really cool. Like whatever you're willing to talk about, but like, what are the first types of transactions or actions that users will be able to do with this? Because this sounds really nice.
Yeah, so we first gonna build that just in the SDK. So we don't want to like expose it directly in our front end per se,
Okay.
because it's like another project in of itself, and we have another interesting thing to focus on. Shortly, we will talk about that as well.
Okay.
So we will implement that in SDK, such that you can take our SDK, you can create a swap and specify the exact calls that should happen on the other side, and then the swap is created, and then upon settlement, these actions are executed. So you can integrate it into your solution to have that. And we have been talking with StarkNet, so they want to have this earn portal where this could make a lot of sense, where Bitcoiners can just come in and they don't even need to know there's StarkNet behind, and then they just deposit Bitcoin in, and they would use our SDK in the background to do that. And also, like for example, Bravos, which is the wallet that we are integrated in, already do something similar, because you can actually get yield on the incentivized yield on Bravos by bringing the BTC there, and they integrated our SDK to do the swap part. But then they had to build their own infrastructure to do these automated actions on their end. So it actually already works in Bravos, but we were just making it much easier for other people to add this as well, by enshrining this into the SDK itself.
Okay, cool.
No, and the really cool part is that, like, for the cross-chain swap, which is like the most vulnerable part, and this is also how we all know where most of like the DeFi hacks actually happen.
Yeah.
This is still secured by Bitcoin and with Atomiq, and then we basically just hook in, for example, another DEX, a lending protocol, or something else on the destination chain.
Gotcha.
Yeah, right. I mean, with DEXs, it also gets really interesting because you get access to all the tokens on the chain, right? And it's very capital efficient on our end because we just bridge to a single asset, and then all the swaps that need to happen on destination.
Yeah.
Capital efficiency is actually a very good keyword here, because that's something that we haven't really talked about yet, because we're using RFQ, request for quote, and compared to like an AMM pool, we're not dependent on slippage. So with our system, a customer gets like a binding quote from a market maker directly, which also means that, like, for example, to swap 1 million, I think with an AMM, you usually need to have like a 100 million pool in order to like get around 1% slippage. So this is not the case for Atomiq. Our LPs basically need to have like 1 million in their node, and this is what they can swap without any price impact.
Yeah.
So the system can get like up to like, I think 100x more capital efficient.
Wow. Yeah. No, totally. I mean, especially at that sort of scale or volume, this becomes really, really important. I mean, anybody who's played around with like random DEX tokens has gotten completely killed by slippage, and that's why people use Curve for Stablecoins, for example. But yeah, that's great. So it's just like a predefined. It's like an order book, right? RFQ request for quote. Basically,
it's not really order book. Like it's very simple. You just have a network of liquidity providers. You send a quote to each of them, and you get quotes back. And then each of these quotes is binding quote, and then you just execute the one that gives you the best pricing. It's a really simple system.
Gotcha. But it's like defined. It's peer to peer, like you said before. So okay, yeah.
And that's another cool thing. Like there is no Atomiq in between. When you go to our website or when you integrate the SDK, the request goes directly to the LP. There is no like Atomiq proxy to get all the requests in and then forward. So even if we would disappear, you could still use the Atomiq. You could still swap.
As long as the operator is still running, I guess.
Yeah, exactly. I mean,
yeah. Cool. Very, very cool. Wow. Yeah, this is a whole new way to think about moving assets between chains that I hadn't really thought about. I'm usually thinking about ZK based stuff, which in this case maybe is an overcomplication or not even possible because of Bitcoin's technical specifications. But yeah,
ZK is actually also a very good keyword, because like for us, our mission is basically like we want to make trustless interoperability real, starting with Bitcoin cross-chain swaps. But our vision is a much bigger one. We actually believe in like a multi-chain world with Bitcoin security underneath everything. And everyone in cross-chain usually always thinks that like ZK proofs are the end game. And with what we have in store, or what we have planned, we can give you the same or even slightly better trust assumptions than ZK. And we can enable swaps between any smart contract eligible platforms, blockchains. So basically, we could do swaps between Solana and Ethereum and secure them with Bitcoin, how I like to say, as a dispute settlement layer. So let's say if both swap parties cooperate, then like the swap would be instant. If not, and let's say like either the LP or the user is trying to ruck the other party, then we can basically use Bitcoin as the dispute settlement layer.
Okay.
Yeah.
Okay.
That goes into what I was saying. Like, this is something that we are building towards. Is like we will use Bitcoin to secure all cross-chain swaps between all the chains, and we can do so without using ZK. Because I mean, like these ZK proofs, like they are cool, and I'm a big believer in that, but they are still not there, or they are like still not widely used for cross-chain bridging, because you have the latency issue. So it takes time to compute a proof, and then it adds latency to the swaps, or if not to the swaps, it adds latency to the settlement, which is even worse, because then you shift the liquidity requirement on the part of the LP, right? Because now he needs to bridge that settlement, like swap happening to settlement liquidity. And you also have like a lot of off-chain costs when it comes to proofs, right? Because you need a big proving infrastructure to prove a light client of another chain. And not to say that for Ethereum, the light client, the sync committee is a joke, right? Like it's like 256 randomly sampled people of the validator set, and then they just sign something, and they are not even held liable for that. There is no slashing for that. And then go into things like, okay, like prove Solana with 400 millisecond block times. Like how do you even have a proving infrastructure that keeps up with that, right? Like you can, but the cost of doing that is gonna be quite high. So we are really pragmatic about this. We said, okay, maybe there is a better way, and we found a better way that, as Sylvie said, we're gonna do swaps that are settled pretty much instantly when both parties cooperate. But in the case of something going wrong, there is always a way how to force settle the swap, or by using Bitcoin as a settlement layer to basically send a certainly crafted Bitcoin transaction to force settle both legs of the swap, be it between any two chains.
I love this because this is what it's like. We've come from the beginning explaining everything to the title of the stream today. Bitcoin is the settlement layer for all cross-chain swaps, and I was going to directly ask you to explain that. Like, okay, let's break this down. But I think you just did that. So
I try to. I'm not going to spill the beans exactly of how this works, obviously, but just to stay tuned. I mean, this is something that we will like begin work on like quite in the near term, and I'm really excited about this because at first I was a little bit like tolerating these like multi-sig based, validator based bridges and swap solutions, because I was like, okay, yeah, like ZK is not there, so I mean maybe this is the best we have so far. But now I'm like, okay, like I think they're just garbage. Like we have this much better solution which can do things fully trustlessly, and yeah, now I don't hold any respect anymore for this like multi-sig based bridges, because yeah, there is a way to do it better, and we will do it better.
Yeah, and I think one of the problems we haven't even touched on when it comes to like validators or multi-sigs, because we always assume that it is different people operating them. But there were like bridges in the past, I'm not going to name names, but yeah, where, for example, the CEO of the bridge was actually like controlling all of the multi-sigs himself. Yeah. And this is another problem, because you never know.
Yeah.
Unless they disclose who the validators or multi-sig holders are, you simply don't know one person.
Yeah.
Even if they do for this project you're mentioning, and we're not going to name names, these people, they thought they have control of their validators, but in the end they realized they do not, because the CEO just shut them all down. So it's like it's very hard to like prove that in a federated systems, and even in proof of stake systems, right? Like generally project starts with like quite a big allocation of tokens to themselves, so they have like a big control over the token distribution, and that means that they have a an easier way to just capture a big chunk of the multisig and to be able to control the protocol.
Yeah.
Yeah, and that comes back again to us being
people
secure.
Yeah. This stuff is super important, and I really do love the whole story of you two wanting to build this, because this is a product that you want to use. You want this product to exist. That's like build the thing you actually want to use. That's
I think everyone needs that. I mean, they might not know it that they need it, but they surely will know if something breaks and their bridge that they are using rugs them. Then they will know, and then they will start asking like, oh, how is it that you said this is trustless and permissionless, yet I got rugged? And
totally.
Yeah, because in the end it's like security doesn't matter until it does.
I was going to say the exact same thing.
Well, great minds think alike.
Yeah, you took words right out of my mouth. I have like one last little anecdote here, which is like, I mean, I think in the 3.5 years that I've personally been in crypto, I've seen user experience really improve. I mean, embedded wallets, account abstraction. Again, my attention has always been focused on Ethereum and like L2s, but the UX and fees and throughput, it's all kind of improved there. Like when I first started playing around with Ethereum, I was like, okay, it costs more gas to do this swap than the value of the swap I'm trying to do. So I can't use a DEX. And DEXs can still be expensive, but anyway, I've seen like a lot of things advance in that time. But still, like I used a bridge recently to go between, don't ask why, but I needed to put some stablecoins on BNB, or like Binance Smart Chain, going from Ethereum, and I used a bridge that I had used in the past between Ethereum and some L2, and it worked fine. And then when I used it, I got really scared. I'm like, did I just get rugged of $500? Because basically the solver didn't have enough USDC on BSC to fulfill my swap, but I'd already sent the funds. And I'm sitting there for like 8 hours, going into their Discord, opening tickets, sending stuff like, why is it not showing up in the UI? And this just happened like 4 months ago, like 6 months ago. This was recent, and this is a bridge that I've used a bunch in the past. That has a lot of volume. And I'm like, this is not acceptable.
And did you get refunded in the end, or what happened then?
The transaction went through eventually, but I was worried.
A similar thing just happened
it took
to
like
me,
8 hours, and it was just like whoever.
Yeah, like the very same thing happened to me just when the big crash happened. I think it was like five days ago, like on the 10th, right? On Friday. Like I was trying to move some money into Paradex, which is this like app chain on StarkNet for like perps trading, and I use one of the bridges, and like I sent the money in, and then it said like transaction failed, and then like nothing, no button to refund, no info. Well, like what happens now? And of course I didn't receive the money on the other side, so I was like, okay, maybe I just lost like $1,000. But then eventually it just came on the other end, even though in the bridge it said it failed. So I have no clue what's happening there.
Yeah, I know. And like I guess we're pretty experienced crypto users, like, and that's still scary for us. Never mind new people we're trying to onboard, like, so yeah, I'm happy that you guys are working on a trustless solution for this kind of basic thing, even that maybe people don't realize is even needed until it is needed.
I mean, it is needed. It's just that the way, like it's also like other competitors are doing it in the market. It's just that the way they're doing it, it's like not trustless. It's custodial, really. And that's what we really like to change. And it's as you said, like it's this like a primitive almost that should be there, and then it's crazy that it still isn't. Like crypto's been around for what, like 15-16 years now, and yet as Vitalik even wrote back in, when was this, Sylvie, like 18, 19,
I think
20?
so, yeah.
Yeah, that like we should put resources towards building a trust minimized bridge between Bitcoin and Ethereum, and that still to this date hasn't happened.
Wow.
I think that's a very good closing statement.
Yeah. Agreed. Well, yeah, Sylvie, Adam, this has been amazing. I'm having a blast. I think I could talk to you guys for another couple hours at least. Before we wrap up, do you have any closing things you want to add? I mean, we already have a great closing statement, but calls to actions, things you want people to check out. Yeah.
Yeah, I mean, we have a website, which is atomiclabs.com. Atomic with IQ, not IC, because if you're using us over another bridge, then you have a very high IQ. Haha. Yeah. If you want to use the exchange directly, it's atomic with IQ.exchange. We also have a Twitter account, which is Atomiq Labs. Go follow us if you have any questions. We also have a Telegram community that you can join. You'll find the link to it in the link tree on our Twitter page. And yeah.
I think Twitter is really like the best place to follow us. Like we were posting frequently there. There is like links to every other thing, all the other things there. So yeah, definitely like go give us a follow.
Awesome. Well, yeah, and if you're watching this recording in the future, these links will all be included in the description in YouTube. I can like point down, like go to the description. I'm not a YouTuber. I need to get better at some of this stuff, but yes, it should be there if you're watching this in the future. And if you're not, you're watching this on Twitter, and they're tagged, and you'll see the links on the aligned accounts. So once again, Sylvie, Adam, thank you so much. This was a blast. I'm excited to see all the new stuff coming up from Atomiq in the future, and looking forward to the next time.
Yeah, thanks a lot for having us, Boris. We had a great time.
Thank you. See you.
But I'm glad. Okay. Bye.